Imagine a world where, instead of worrying about overflowing landfills, polluted oceans, and the endless cycle of waste management, humanity simply packed up its garbage and sent it into the vast, seemingly infinite realm of space. It sounds like a bold solution, out of sight, out of mind, a cosmic trash can that could theoretically solve one of our biggest environmental challenges. But beneath the surface, this idea sparks a whirlwind of scientific, logistical, ethical, and environmental considerations that reveal just how complex the notion truly is. To truly understand this concept, let's start by examining the scale of our waste problem here on Earth. Every year, humans generate billions of tons of waste worldwide, from municipal solid waste, including plastics, paper, food scraps, and metals, to hazardous, industrial, and electronic waste. The sheer volume is staggering. Landfills are filling up, plastic debris is choking our oceans, and many countries struggle to manage the waste they produce. The environmental damage is undeniable. Greenhouse gases from decomposing material, toxins leaching into the soil and water, and the tragic impact on wildlife and ecosystems. Traditional methods of waste management, landfilling, recycling, incineration, each present their own challenges and limitations. Landfilling takes up valuable space and causes pollution. Recycling has limits in scope and efficiency, and incineration, while reducing volume, can release harmful emissions. With these mounting pressures, the idea of sending waste somewhere far from Earth's environment, into the deep, dark void of space, has a certain allure. Surely the cosmos is so vast and empty that it could swallow our refuse with no consequence, right? Yet, once we peel back the layers, the challenges of such an endeavor become apparent. First, let's tackle the most straightforward question. How would we get our garbage into space? Launching anything from the surface of Earth into orbital or beyond orbital space is a monumental feat requiring rockets, which are both technologically complex and extraordinarily expensive. Rockets are engineered to carry valuable scientific instruments, satellites, astronauts, and interplanetary probes. The cost to launch a single kilogram into low Earth orbit is tens of thousands of dollars, and much more for deep space launches. For context, an average household in the United States produces over 2,000 kilograms of waste per year. Multiply that by millions of households, and then by all the businesses, industries, and governments worldwide. And the numbers become astronomical. Each launch would only hold a relatively modest payload compared to our total waste output, meaning millions of launches per year would be required to make a dent in the world's garbage problem. Now, consider the environmental impact and risks associated with rocket launches themselves. Rockets burn huge amounts of fuel, creating significant air and upper atmosphere pollution, including black carbon and other greenhouse gases. A surge in launches could affect not only Earth's environment, but the delicate composition of the atmosphere. Moreover, rocket failures are not uncommon. If a garbage-laden rocket were to explode shortly after launch, the debris would rain down on Earth, dispersing waste over potentially wide areas, undoing any benefit and creating hazardous situations. Let's assume, for argument's sake, that advances in rocket technology dramatically reduce costs and environmental impacts. Let's even imagine that we invent a hypothetical, near-magical propulsion system, clean, reliable, and inexpensive, capable of frequently and safely launching enormous quantities of garbage away from Earth. The next key question is, where exactly are we sending the waste? Outer space may seem limitless, but it is not devoid of rules, boundaries, or consequences. The region closest to Earth is low Earth orbit, already crowded with satellites, space stations, and thousands of pieces of debris. Anis, defunct satellites, rocket stages, and fragments from collisions. Adding more waste to this environment would only compound the growing issue of space junk, posing hazards to working satellites and spacecraft. This is a risk-filled proposition. Even tiny pieces of debris fly at incredible speeds and could cause catastrophic damage. Could we simply chuck the garbage farther afield? The next nearest celestial body is the Moon. landing waste on the lunar surface would present challenges similar to any lunar mission. Precise navigation, landing fuel, and costs multiplied many times over by the volume of waste. Not only would this risk contaminating a body of significant scientific interest, but legal and ethical ramifications arise regarding the preservation of the moon, seen as the shared heritage of humanity. We could, perhaps, envision jettisoning garbage directly into the vastness of interplanetary or interstellar space. This, however, requires even more energy and expense. The velocities needed to escape Earth's gravity and the Sun's gravitational pull are immense. Each ounce of waste sent out of the solar system would carry an immense financial and resource burden. Additionally, the mere act of sending materials on a collision course with other planetary bodies or risking the introduction of terrestrial organisms into space is heavily scrutinized by planetary protection protocols. International agreements intended to safeguard potential extraterrestrial life and keep Earth clean of unknown cosmic pathogens. Some might suggest incinerating the waste in Earth's atmosphere via controlled re-entry, allowing it to burn up, but this approach is not risk-free either. Not all materials fully incinerate, and some can produce toxic clouds or survive impact to the ground or ocean. Apart from logistical hurdles, sending garbage into space brings up a host of ethical and philosophical questions. Is it responsible to export our waste beyond our own planet? Should we concern ourselves with the unintended consequences this might have for near-Earth space and the wider cosmos? There are precedents in history. Out of sight often meant out of mind, at least until consequences return to haunt us. Humanity must consider whether pawning off its pollution on the solar system fits the narrative of stewardship and sustainability we now recognize as so vital. Let's dig deeper into possible solutions and the science behind each. First, rockets. Could new technology revolutionize the cost and scale of space waste disposal? Space agencies and private companies are pushing the boundaries with reusable rockets and more efficient propulsion systems. Companies like SpaceX, Blue Origin, and Rocket Lab have made significant progress in reusability and lowering launch costs, but the gap between launching a satellite and launching thousands of tons of trash remains vast. The Saturn V rocket, the largest ever operational, could carry about 140,000 kilograms to low Earth orbit, and even that would require a huge investment and create massive volumes of emissions. To manage just the United States municipal waste in this fashion would require thousands of launches every day. Suppose we could build a space elevator, a far future concept involving a tether anchored to Earth and extending into space, used to ferry payloads up and down at a fraction of current costs. Such a structure would revolutionize access to space, making mass transit of material more viable. But building a cable strong enough for this purpose would require materials beyond our current capability, like perfect carbon nanotubes or graphene. Even then, launching garbage steadily into orbit would threaten the surrounding space with debris if accidents occurred, not to mention increased satellite navigation issues. Another imaginative concept is the use of solar sails, large, lightweight mirrors that ride sunlight pressure to steadily accelerate cargo out of low orbit and toward deep space. Solar sails move slowly but can, given enough time and the right trajectory, remove material from near-Earth space. Yet solar sails are suitable only for small, lightweight payloads, and garbage, especially hazardous, dense, or massive, may not be practical for such a system. Some advocates have suggested targeting the sun itself, launching garbage on a trajectory that would see it fall inward and burn up completely. At first glance, the sun appears to be the perfect cosmic incinerator, unimaginably hot, vast, and far away. However, paradoxically, it is far more challenging to send something into the sun than simply out of the solar system. An object in Earth orbit is moving at 30 kilometers per second around the sun. It would take a tremendous amount of energy to nullify this velocity so that an object can fall straight in. It's easier to fling something away from the solar system, as spacecraft like Voyager have done, than to drop it into the very gravitational well at the center. Even if we were to surmount these formidable obstacles, What sort of waste would we want to send? Some materials pose extraordinary danger here on Earth. Radioactive waste, high-level hazardous materials, or perhaps plastics so persistent they never break down. Selective launches might have merit. An occasional special mission to dispose of waste that is uniquely risky and otherwise impossible to neutralize. Still, the peril of an accident mid-launch, scattering the very worst substances across the planet, is sobering. Consider the environmental and cultural impact. Earth is unique in the known universe for the abundance and diversity of life it harbors. Our relationship with our home planet is undergoing a transformation. From seeing the Earth as an inexhaustible resource to recognizing it as a fragile oasis in space, whose well-being is tied to our own survival. Sending garbage into space can seem like abdicating responsibility, trading short-term convenience for long-term uncertainty. Do we want to risk turning the near-Earth environment, the Moon, or even interplanetary space into extensions of our landfills, especially when other civilizations, if any exist, might someday encounter our refuse? Space law and governance add another layer of complexity. The Outer Space Treaty, signed by over 100 nations, stipulates that celestial bodies should be preserved for the benefit of all humanity and protected from contamination. The idea of exporting our waste into these shared spaces would trigger immense debate and likely opposition from the global scientific and policy community. Moreover, the history of waste exports here on Earth provides a cautionary tale. Efforts to ship hazardous waste to other countries or dump it into the oceans have ultimately resulted in environmental calamity and global outrage, as well as new systems of international regulation. Space, being the ultimate international domain, would present similar, if not greater, challenges. If we step back from the wild idea of launching trash into space, the very act of considering it can offer meaningful lessons. It highlights just how significant and urgent our waste problem is. It demonstrates the need for innovation not only in disposal, but in reduction. Preventing waste is always better than finding radical ways to hide it. A more sustainable approach would prioritize circular economies, reducing, reusing, and recycling over simply shifting the problem elsewhere. Technological advances in waste processing offer promise. New materials designed for easier recycling or composting, enzymes that break down plastics, and industrial processes that turn waste into energy or building materials can all play a part in reducing our landfill burden. Cities and countries pioneering zero-waste policies are showing that with education, investment, and commitment, societies can dramatically cut their waste streams. These are the types of rocket science solutions that happen right here on our own planet, and perhaps represent a wiser investment of our resources and ingenuity. One day, if we become a truly spacefaring civilization, establishing permanent settlements on the Moon, Mars, or further afield, the management of waste beyond Earth will become a practical necessity. Future colonists will grapple with how to recycle, repurpose, or dispose of waste far from the infrastructure and resources of Earth. In these distant outposts, every atom may become precious, and the lessons learned from Earth's struggles with waste may serve as a guide. Maximize reuse, minimize disposal, and treat every resource as valuable. Closing the loop, humanity's quest to handle its garbage invites a choice. Spend vast fortunes launching refuse into the unknown, or invest in systems of stewardship, innovation, and responsibility that cherish our only home. The dream of sending all our garbage into space captures the imagination, a technological leap, a final solution to decades of struggle. Yet, the closer we examine it, the greater the wisdom in addressing the challenge where it truly lies. Not in the stars, but firmly rooted in the way we live, consume, and care for the planet beneath our feet. For while space is boundless, our ingenuity and capacity for stewardship may prove to be our greatest assets of all.